In the last video, we went over the idea of the for each method and how it can provide some powerful automation to the functions that we give it. The for each method essentially abstracts away a for loop that would iterate over an array, and within the function, of course, we can do whatever we instruct each value. We can do whatever we want to it. But this is still a pretty basic function, and there's a few other really great array methods that add a little more complexity. You can essentially do the other things in a for each method, but the ones I will introduce you to in just a minute will abstract away even more of this logic and make your workflow that much more amazing. So the first thing we want to look at is the filter method. The filter method, and before I get too far ahead of myself, let's just make an array variable. So the filter method, it will be chained off an array, and it will take a callback function just like the for each, but unlike the for each, which doesn't expect you to actually return anything back, the filter method and all these methods will require something to be returned, and what gets returned will be interpreted by this method and will determine what the actual final output of the method is. So let me start typing it out so it makes a little more sense. We have our array variable, and we will do filter. And it takes a function, first parameter is the value. Can also take the index and the array itself. And for each one, it will run this function, and whatever gets returned, it's expecting a boolean to be returned, either true or false. And whatever gets returned will determine if that particular value stays in this array or not. If we get true, then the number or whatever the value is can stay in the array. If we get false, it gets removed from the array. So a real easy first one, we can say, return if the value is less than 4. So anything less than 4 returns true. If we run this function now, you see we get back 1, 2, 3. We don't get anything else greater than that. Of course, if we have greater than or equal to 4 and we run this, we get back 4, 5, or 6. We can do something like return value modulo 2 is equal to 0. This will return back all even numbers. We got that there. Or we can return back all odd numbers right there. We can compare it to, let's say, the index. Return if index, let's say we can return, so if the value is also equal to the index, it gets taken out. And of course, none of these values are equal to the index, because that's index 0, index 1, index 2. But if this index 2, we made 2 right here, that second 2 gets taken out. So there's some fun things we can do with Array.filter. We can also use Array.map. I think Array.map is especially useful. It will take each value, and what it's expecting, it'll pass it into a function. Again, the function is the same thing. It's going to pass the value as the first parameter, the index as the second, and the array itself as the third. But what it will return, whatever we return, is going to replace the actual value that we started with. So if we have Array.map function, I'll just type out the value. And actually, I'll do this first. Value and the index. And we return just the index. We are essentially ignoring the value, and we are just returning the index. If we run that, and the way this REPL works is that we return the last function that's made. So this is running, but we don't see this. So we're on Array.map. It's essentially just mapping the index numbers of an array. not too exciting. You know, we could make this array of a double array of 2 and hello and null. And we pass that. It doesn't matter. It's not even looking at these values. It's just looking at the index, which is always 0, incrementing by 1 from there. Let's say we can return, let's change this array back to the numbers. There we go. We can do something like this. We can say, let's return value times 2 plus the index. Now if we run this, we get a transformed array that's quite different. You know, we have 1 times 2 is 2, plus the index of 0 is 2, then 2 times 2 is 4, plus the index of 1 is 5. Same number again, but the index is 1 higher, so it's 6, and on and on and on. So that's pretty cool. Finally, we have the reduce method, and it's probably most famously done for getting the sum of an array, which is what we'll essentially do here. We have Array.reduce, and this one works a little bit differently than the other two. It's going to pass a few different things into the function. It's going to pass a previous value for the first argument and the current value for the second argument. And in this function, it's going to expect something to be returned, and whatever gets returned is going to be the new previous value. So it seems, you know, a little strange, and the way I learned it was, let me put this back down here for context, take these away. The way I kind of learned it, and I liked this this image, was the idea of a snowball that's just gathering more and more values from the beginning all the way to the end, and this previous parameter is that snowball. We'll log these things out too so we can see them. The previous value, and we'll say previous, a current value, that is cur, and then we'll return previous plus current. And the colon should be inside the quotation mark there. Alright, if we run this here, we can see on the first pass, previous is 1, current is 2. There's also something interesting. When we start here, it's actually starting 1 at index 1 as the current. Since there's no previous yet, it automatically makes this the previous one. So it passes that into there, passes the 2 into the current, and then starts computing. So it says previous is 1, current is 2, it adds that together, it makes 3. And then the next pass, 3 is the new previous. And the next current, which is another 2 right here, we'll add that to that, get 5. You see 4 plus 5 equals 9. The 9 is right there, plus 5 is 14. And the final current is 6, which gets us 20. Now, we can specify an initial value like this. This is actually the second argument in this function. If we specify this 0 here, then this gets passed in as the initial previous, and then we actually start at the beginning of the array as current. So as you can see here, we now have that 0 passed in, and we start with this one right here. This essentially does not change how we've made the logic here, but it's usually considered better practice to have this initial starting value as well. So you know, we are starting at 0. That way, you know, if we just have an empty array, we get a 0 back. And if we didn't have that, we'd get reduce of an array. It has no initial value, and there's nothing else it can use. So using an initial value always kind of prevents some potential errors and bugs in your program like that. And with that, happy transforming, reducing, mapping, and filtering your arrays.